Okay, today we are doing module 5, chapter 5, where we're adding and subtracting fractions. So this is not anything new. This is just continuing with what we already know and really just kind of reinforcing the information that we already have about common denominators and unequal denominators, what that means and how to use those things in order to just add and subtract fractions. So let's look at the problem. Okay, so we have Malia bought shell beads and glass beads to weave into designs in her baskets. She bought 1/4 pound of shell beads and 3/4 pounds of glass beads. How many pounds of beads did she buy? So first of all, I'm going to underline the question I need to answer, which is how many pounds of beads did she buy? It's important to understand that no matter what, we need to understand what problem is actually asking. So I'm trying to find the total amount, right? I'm trying to find the total, therefore I'm going to be adding. And so I'm going to circle the information I'm using, which is 1/4 of a pound and 3/8 of a pound. So before I even go any further, I already noticed that my two denominators are not equal. So I cannot just add these across. I can't just add the numerators and add the denominators. That's not how it works. I know that I have to change one or both of my denominators in order for me to be able to solve my problem here. So I'm going to write it in its simplest form. So one way we're going to do this is we're going to just multiply my two denominators together to get a common denominator. You can do this anytime. You can always just multiply them across in order for them to be common denominators. So 4 times 8, I know that's 32. So then I'm going to use that to write an equivalent fraction with equal denominators, and then I will add. So in this case, I know I'm going to get to 32. That's going to be my denominator, right? So 4 times 8 gets me 32. That means that my denominator, whatever I do to my denominator, I have to do to my numerator. So I multiply 1 times 8 and get 8. So then I know that the inverse is true, right? I can do 4 times 8, meaning I can do 8 times 4. So 8 times 4 means I do 3 times 4, and that becomes 12. So then I just add my numerators. My denominator stays the same every time. 8 plus 12. 8 plus 2 is 10. So again, I get 20, 30 seconds. So I can't leave it like this. I have to do what's called simplifying, right? So I have to simplify this. And I think about all of the things that I can divide 20 and 32 by. But I know that the biggest number I can divide by is 4. So I divide both my numerator and denominator by 4 to simplify my fraction. 20 divided by 4 is 5. 32 divided by 4 is 8. So 5/8 is my final answer. Okay. So the other way we can do is just to find the least common denominator. So the least common denominator of 4 and 8 is 8. I know that because whenever I list out my 4s and my 8s, whenever I list out my 4s and my 8s, I know that if I list out my multiples, I get 4 and 8, and I get 8. So that's going to be my least common denominator. My least common multiple, meaning I multiply my number by another number and get these answers, my product, right? So 3/8 is already ready for me to add because I'm using that same common denominator. Here, I need to change 4 to 8, and I know that I multiply 4 times 2 to get 8. So then I multiply my numerator also by 2. 2 times 1 is 2. I add 2 plus 3, and that's 5. And my denominator stays the same, and it's 8. So both of my answers are equivalent to 5/8. So let's discuss why my answer is reasonable. So one of the reasons why is I can look at both my answers that I got, and I see that they are equivalent, right? I see that both ways, whether I did it the first way or the second way, I got the same answer, which is 5/8. So I could think about it in an estimation perspective. So if I thought about just doing estimation using 0, half, and 1/2, right? I know that 1/4 is closest to 0. And I know that 3/8 is really close to half because 3/8, 3 is almost half of 8 because 4 is half of 8, right? So 0 plus a half is a half. 0 plus a half is a half. And then 5/8, because my answer was 5/8, I know that that is really close to half as well. So I know my answer is reasonable because 5/8 is close to a half. As simple as that. I know that 5/8 is just 1 over my halfway point because halfway is 4/8. 5/8 is just a little bit over that, so my estimation is half. Therefore, my answer makes sense. Okay, so now I'm going to do this example up here. So when subtracting two fractions with unequal denominators, I can follow the same steps that I do when I add two fractions. However, instead of adding the fractions, I will subtract. So just like I did on the previous page, I'm doing the same thing but with subtraction. So first of all, I need to figure out my common denominator. My common denominator. In this case, I know right away my least common denominator between 5 and 10 is 10. Because 5 times 2 is 10, and 10 times 1 is 10. So my least common denominator is 10, which means I don't have to do anything to my 9/10. It stays the same. However, I do need to multiply 5 times 2 to get to 10 as my denominator, and then I will multiply 2 times my numerator, which is 4. So then I'm just going to subtract. 9 minus 4 is 5. 10 minus 10 and 10 stay the same, right? Okay, make sure that you keep the denominator the same. It's almost like whenever you have inches, right? If you subtract 2 sets of inches, right? I subtract 12 minus 3 inches, right? The inches stays the same. It doesn't change. That's the same thing going on here with my denominators. So whenever it says to describe the steps I took to solve the problem, I am literally just using words and writing out exactly how I solved my problem. So the first thing I did was I find the common denominator. Next, I write equivalent fractions. Then I write, equal fractions with equal denominators. Then I subtract and simplify. So if you do notice, 5/10. 5/10. I can simplify that because I know that I can divide both 5 and 10 by 5, giving me 1/2. So I'm going to think about this in estimation terms as well. So 9/10 I know is close to 1/2. And I know 2/5 is close to a half. So if I subtract 1/2 minus a half, I get a half. And in this case, this is exact. So I get two equivalent fractions. So I know my answer is reasonable because so I know my answer is reasonable because my estimate is an actual answer of 1.5. Right? So in this case, it just worked out very nicely, but it's not always going to look like that. So just a couple more examples before I send you off to do it on your own. So I'm going to look at 2 and then 5. So 2, I look at 5 and 7, and I know that my least common denominator, I'm going to use the numbers that are multiplied together, so 5 and 7. So 5 times 7 is 35. And that's going to be my least common denominator here. Sometimes it's just how it works. You have to multiply the two numbers together to get your least common denominator. Sometimes that might be your only common denominator. So here, I'm going to change both of these numbers. So I know that they're going to end in 35. So I'm going to multiply 5 times 7. Whenever I do my denominator, I do my numerator. 2 times 7 is 14. Same thing here, the reverse, right? 7 times 5 and 30 times 5. So 30 times 5 is 15. I add those two together, and I get 29/35. This number I cannot simplify because 29 is a prime number. So 29/35 is what I'm left with. So number 5. Least common denominator. So I'm looking at 4 and 7. And I think, well, I think the only common denominator is 28. Because that's the two numbers multiplied together. So I'm going to do that. So I'm going to have 4 and 7. So 4 times 7 is going to get me to 28. So that means 1 times 7 is my numerator. 7 times 4 gets me 28, and 1 times 4. So now I'm going to subtract. 7 times 4 is 3, 28. So this right here, I know that 3 cannot go into 28. So this is my final answer. I don't do anything different. That stays the same. And I can always, and I recommend this, I can always go and I can check my estimate too. So I could go back to both of these problems and I could do my estimate just like I did on the first two examples. And that would help me to see and know what my answer is. It would be easy to just go back and check, and then I can make a prediction and see whether my answer is reasonable or not. And even whenever I get into, anytime I get into any of those things, and I look and I go back and I see, and I use estimation for really anything, it will help me to make a reasonable answer, especially whenever it comes to multiple choice. Right. So I'm going to look at these algebra ones because I think that these are important to understand. So just like I did on my other problems, I'm still going to find my least common denominator. So I already know my least common denominator here is 10 because I used 10 and 5 just a minute ago. So I'm going to change this number to be a 10. Right? So now 9/10 minus something tenths is equal to 2/10. Well, I know that if I'm doing subtraction, the opposite is addition, right? So 2 plus a number is going to get me to 9, right? Or I could even swap it and think about 9 minus 2, right? So 9 minus 2 would give me 7. So my missing number here is 7/10. On 16, I see that my least common denominator is 12. 12 right here, I gotta change that. I gotta multiply those both by 6. 2 times 6 is 12. 6 times 1 is 6. So now 5 12 plus something 12 is going to give me 6 12. Well, I know that 5 plus 1 gives me 6. So 1 12 is my missing piece. Those aren't as complicated as they look, I promise. It's just going kind of backwards and looking at it a little bit differently to find that missing piece. So that is all for module 5.5. For practice, I would go and I would take this and I would do as much as you can. I assigned odds in class, so I hope that my students all have gotten that done and they understand it. And if they need any help, just let me know.